So we're back in section 9.1 part 2, and we're going to be talking about the confidence interval method. It's important to note here that we might not get the same answer in a confidence interval method for dealing with two proportions. So this wouldn't be the best thing to do, but it's interesting to see how they vary. So just a reminder for the confidence interval estimate. This is important here for determining the confidence level for your confidence interval. Here are the different significance levels, and then you can determine the confidence level based on the type of the test. So we're going to construct a confidence interval estimate of the difference between the population proportions. And this is important. This is what we will determine. If the confidence interval estimate does not include 0, then we have evidence suggesting that they're different values, that they're not the same. So that's the information that we gather from confidence interval estimates. This is how we'll type them into the calculator. We'll be using the 2 proportion z interval, and we'll need the number of successes, observations, and the confidence level. The margin of error here, we can use the p hat 1, subtract p hat 2. We can take the upper and minus this, and that will give us our margin of error. So we're using the same sample data from example 1 to construct a 95% confidence interval estimate of the difference between the two population proportions. So what does the result suggest about the claim? So remember that for example 1, the claim was that they are equal. The claim was that P1 is equal to P2. And so let's take a peek here. We'll go into our calculator, and we're going to go into our stat and tests and 2 proportion z interval, confidence interval. And so we need x1, n1, x2, n2. So from example 1, we get 239 and 2040. That's the Connecticut. And it's also right here, 239, 2040. And then x2, this time is 9 and 541. And our confidence level is 0.95. So when we calculate that, we get this interval here, 0.082, 0.0828 is less than proportion 1 minus proportion 2 is less than 0.11776. So the question here becomes, is 0 included in this? Is 0 included? And it is not. These are all positive numbers. So because 0 is not included, if we go back here, we have evidence suggesting that they're different values. So this says, do they have the same proportion? And again, it does not include 0. So we believe that they are not the same. So they would be not the same because they do not include 0. And then here's an interpretation as well, just from the textbook. Now, I just want to bring your attention back to if we had to find the margin of error. We could take the upper limit here. So here's our upper limit. And we would take our upper and we would subtract it from the difference between p hat P1 and P2 hat. So that actually can come from the calculator right there, p hat 1, p hat 2, and then we could just figure out the margin of error. So let's do one more example. So in this one, we're talking about the cars and trucks again. And so we're just going a step further, test the claim by constructing an appropriate confidence interval. So for example 4, here we're talking about, remember the claim is that cars are violated at a greater rate than trucks. So if we want to construct a confidence interval, first we need to figure out the confidence level. So because we're dealing with a 0.05 significance level, and it is a one-tailed test, it's a right-tailed test, the confidence level would be 90%. Because we want to have symmetry on either side there. So that we're going to be doing a 90% confidence level here. So we'll just type it right into the calculator. So we'll go into stat, test, two proportion Z interval. And our cars, we have 239 and 2040, but now our X2 is 45 out of, what's our total? 334. And we're doing a 90% confidence interval. And we get negative 0.051. So we get negative 0.051, less than the difference between the two proportions, which is less than oops, let me grab it back up, 0.0148. So remember, with confidence intervals, we're trying to see, could 0 be in between those? And yes, it does include 0, which makes us think that they could be the same, P1 and P2 could be the same, which means that we can't support the claim that cars are greater than trucks because it might actually be the same. The population proportion might be the same between the two. So there's not sufficient enough evidence to support the claim because the interval contains 0. So go ahead and give this one a try. So you can use the data from your previous U-try. And here's the solution. And that concludes section 9.1.